let me just demonstrate a little bit more of the Splunk here. So let me first get my Splunk server up. All right, and this is going to be Splunk. All right, so I go to splunk.samsclass.info, and it's student 1, student 1. And you've got a Splunk server serving up boss of the SOC, which is this official data. And it's running up a query from before, which is pretty cool. But let me just go back to like HTTP. And 1 to 10, that'll be a good start. Okay, so here's all the HTTP events. And if I put in I'm really not Batman, then I will get the events going to my web server. Yes, this comment by Blaze is entirely correct. Make sure you're on the Ropstein testnet. If you're on the mainnet, then you're using real Ethereum that costs money, and you're not going to get any of that for free. Anyway, now I'm here. Let's see, let's go to list instead of table. All right. And so now I'm seeing these responses, and what I'm looking for is one of these Acunetics, and there it is. Okay, here's something from the scanner. So from this, oh yes, absolutely. Splunk is real important. So that's why I say you're not wasting your time practicing with Splunk. So here, all I did was I searched for HTTP packets to the web server, and a lot of them are from the vuln scanner. So once you find one, then you've got several flags that we talked about before. The attacker's IP is the source of these packets, and that is here, the client IP, this 40.80, and the destination IP of these packets is the web server. So there it is. This address is the web server. And, all right. Anyway, now I want to talk about the brute force attack. Let's go on down to that. We did all that before. Here we are. All right. So, yeah, the brute force attack will start with the HTTP events using the post method. Let me just shove these instructions aside so I can refer to them while I'm doing it. All right. So I'm just going to follow my breadcrumbs. I left some hints before just to guide people through it. So I start with HTTP events, which I've got here. And then I can look at the method. HTTP method is here. And usually it's post or get. Those are the most common method. And if I'm trying to find login events, it's typically post. So these would be post methods logging into my Batman server. And I was 1556 of them. And my instructions say, okay, now exclude the ones from the vulnerability scanner. Now the vulnerability scanner is Acunetics, and it's responsible for a lot of this traffic. So if I don't want to see the Acunetics scanner, I can just remove anything that contains the word Acunetics. So I'll go up here and just put in not Acunetics, just like you would in a Google query. All right. Now I've got a much smaller number of events, so I can get rid of the sampling. And that gets me down to 431 events. And here, I said we expected 441, but that's because I left this in here. I'm really not Batman. And for my breadcrumbs, I didn't mention using that. So let's get rid of that, and I think we might get up to 441. Yeah, that's okay. So this is what it is. This is all the HTTP events of type post that did not come from the vulnerability scanner. There's 441 of them. And now, if you look at the form data, which is here, you see some random stuff here. None of that is too exciting. So if we look at the rare, these are the top values. If I go to the rare values, I get a list here of, it tries to make a graph of them, which is silly, but the statistics tab shows me the values. And down here, I'm starting to see repetitive ones. And here's passwords: Arthur, Big Daddy, Blazer, Fire, and the username is admin. This is a brute force attack. Many login events with the same username and a whole series of passwords. So that's the brute force attack. And one cool way to do it is to make a table. So rather than this form, which is one way to see it, it's even clearer if you make a table with time, underscore time, and then form data. So all I want is the time and the form data. And now I've got a total of 441, and I can sort by time here. So this is going forward in time. So the first one was here using a password of 1, 2, 3, 4, 5, 6, 7, 8. And then this one had let me in, and this one had QWERTY. And you notice they're really fast, like 21.2, 21.24. These many guesses in 1 second, like 6 or 8 guesses in 1 second. And then more here. Yeah, Sumo Logic is similar to Splunk, but much harder to set up. I had it in my projects, and Caitlin was the only person that could make it work. Nobody else could make it work. It's real hard to set up. People say it's better for cloud servers, though. But I was unable to make useful projects for my class out of it a few years ago because it was so hard to set up. Yeah. Anyway, so this is the brute force attack. You can see all these login attempts, and now there's a series of flags you can answer here. Like it asks you, find the IP address performing this attack. So it would be the source address of any of these. And what was the first brute force password used? And what was the correct password found? Because you'll see at the end. So here it is doing many guesses per second. And here I am at 100, and it's still doing this many guesses per second stuff. So if I go to the end on the last page, it's still doing private, and I think, yeah, password equals lifehack, Williams, Godzilla. This is still the many guesses per second. And when I get to the end, here's when something different happened. So what happened is the brute force attack with many guesses per second went on to here, and then there was a pause from 4651 to 4805, and then somebody came in and logged in with the real password, and after that they were in and they started doing administrative things. So this is the brute force attack that was automated. This is the hacker coming in a different browser and now logging in with the password that was found. And another way to tell that is to look at the user agent. So if I go back from this table to seeing all the 441 events that sent posts, which were mostly logins, but not all of them, you can sort them into categories by user agent, which is here. And you'll see this 412 with Python, that's the brute force attack. It's running a Python script trying all the passwords. And, whoops, I hit something. All right. And this is the real attacker coming in, and these are other things that used post but were not part of this. So this is the brute force attack, and this is the actions of the attacker. And you can find out what that person did by adding to that the same pipe table, time, and form data. And then you should be able to sort of trace out the actions of that person. If you sort by time. So here they are logging in, then they install some package, and then they do something with something called Com Explorer, which I think is something they've uploaded, and on it goes. So anyway, I think that's just spam. Actually, it might not be. Let me check. It might be a guy with my keys. Oops, hit the wrong button. Oops. Oh well. Such is life. All right. Anyway, that would actually give you several more flags to do with the brute force attack if you do that stuff. And I think that's probably enough to demonstrate for tonight. How do you master queries in Splunk? Well, I'd start with boss of the SOC, and then you can just go on. And there's cheat sheets as well. Yeah, people have a lot of good tips there. It's really just a database. So If you learn any language like SQL, you'll be learning similar stuff. But I'd say the main thing about it is it's not really Splunk that's hard to use. What's hard to understand is the structure of log entries. What you really need to learn is the structure of Windows event logs and such. So I would recommend just practicing with things like this. Yes, it is similar to SQL. It's very similar to SQL. They wrote this thing called like VQL, their query language. It's essentially SQL. That's what all search languages are. The difficulty is not Splunk. The difficulty is the layout of these events. Yeah, it's just another query language. Yeah. And so the query language is really quite simple. Name equals value, things like not, or just a value to match, and then things like table and stuff. Really only a few parameters that are pretty easy. The only hard part is figuring out what to search for, and that's kind of a matter of practice and understanding log entries. All right, I'm going to stop this recording.